All right, the distributive property. Very, very important in algebra because order of operations tells us we have to do parentheses first. However, x plus 4, I can't do anything with that because one's an x and one's a 4. Like we've talked about, those are different terms. They are unlike terms. And so how we deal with it is we take this 5 and we distribute it. Anytime you have 5 next to the parentheses, this is actually multiplication. And what's beautiful is that you can distribute multiplication over addition like that. So you get 5 times x plus 5 times 4. So you get 5x plus 20. We can do the same thing here. This negative carries on through as well, so you want to make sure you take all of that. Negative 3 times 2, and I'm just going to say add a negative 3 times 3x, so I don't forget to plug in that negative. Negative 3 times 2 is negative 6, and negative 3 times 3x. 3 times a 3 is negative 9, and then we just leave the x there because we can't. That's what it means, is it's multiplying there. Now notice I use dots here and I use parentheses here. They mean one and the same thing because when we write it with parentheses there, it's really meaning multiplication. So we did it with 2 terms. We can also do it with 3 terms. Negative 2 times x plus a negative 2 times a 3y, and then plus a negative 2 times a negative 5. And so this one I kind of like to put in parentheses so I don't think I'm subtracting there. So you get negative 2x. Negative 2 times 3 is negative 6y. And negative 2 times a negative 5 is a positive 10. And so we've got our answers so far. Now, this one, this 3 is connected with the 7 by addition, but order of operations tells us we have to do the multiplication that's in between here first. So I'm going to leave the 7 out in front, that negative 7. And we're going to do 3 times 2x, and then 3 times a negative 6. Again, I kind of like the parentheses for those, but whichever you prefer. 3 times 2 is 6x. 3 times 2x. So you have 6 x's, and then 3 and a negative 6, when you multiply, makes negative 18. Right? And now we have some like terms that we can combine. I like to write my x out front, despite not doing it up here. I guess I could rewrite that as negative 9x minus 6. Either or. And then so you have 6x, and then 7 and 18 make 25. Because they're both negative, they're going to become more negative. So again, this is called the distributive property. And it's very important because we really like to distribute. I want to talk real quick about why it's okay to distribute. Distributive property. Let's say for a second that we have this 2 times 3 plus 5. Now, if you were doing order of operations, let's do it 2 different ways. 3 plus 5 is 8, and you have 2 times 8, which gives you 16. Now, if you use the distributive property, we would do 2 times 3 plus 2 times 5. And then you get 6 plus 10, and you get 16. So it's nice, and it works out because we got the same answer both ways. And so that's why the distributive property works, because you can actually choose numbers, and it works. Now, what I want to show you is that this is multiplication over addition. Multiplication over addition is distributive. But not everything is distributive. For example, 3 plus 4 squared. Let's do this two different ways. First off, order of operations. 3 plus 4 is 7, and 7 squared is 49. However, if you do it distributing this 2, which I'll warn you, this is why this doesn't work. 3 squared plus 4 squared, you get 9 plus 16. And 9 plus 16 is 25. Now, very different, right? And so the whole problem is that this cannot distribute. And you cannot distribute exponents over addition. And so keep in mind that you can't distribute everything all the time. This one works because it's multiplication over addition. And so we'll mess with that some more later on. Why you can't do this? There is, you can distribute exponents over multiplication. Had these two been multiplied, that would have been okay. And I'll show you why that works later on.